Joe is just such a beautiful human being. He will bristle at that, I'm sure, and claim that he's just about posting the trashy memes, but such an analytically just smart person, caring person, loving person. I got to know Joe over a couple of years in his time at Dragos. He's now over at Domain Tools, another fantastic company, as a senior threat researcher. But what really made me appreciate Joe and Joe's digging in his style of presentations is, I think it's fair to say, Joe, that you didn't start out in ICS in your career, obviously with Navy background and everything else. I'm not saying you didn't have any experience, but when you dove into it, you dove in. And you absolutely embrace the community, calling up the vendors. How does this work? Talking to the operators. How does this system work? Let me understand system and substation operations. Like, it was a real thirst to understand the operations and then apply your security knowledge. And it was just best breed in terms of approaching the ICS security challenge. So I won't take up any more of his time, but I'll say pay attention. Joe can talk fast. And that is from a guy who talks very fast. But pound for pound, it's amazing content. And I love how Joe challenges preconceived notions and tries to dig in to bring out insights for folks. So, Joe, my good friend, over to you, sir.
Thanks, Rob. I'm assuming audio is coming over, and do I have control over slides? So my name is Joe Slowick. I'm going to talk about exercising the ghost in the machine, evaluating supply chain attacks. So who am I? My name is Joe Slowick. Rob already provided me the introduction before we had wonderful technical difficulties. Those are always glorious. Prior to my time at Domain Tools as a threat researcher, I spent some time at Dragos in the national labs, as well as US Navy and some other things. And now I work at Domain Tools. You may ask yourself, like, what, Domain Tools, ICS Summit, what's going on here? Well, increased area of connectivity, that network traffic, analyzing who you're talking to and why you're talking to them is pretty important. So continuing to expand and advance my research into industrial control systems, specifically in critical infrastructure more generally in my current role. Moving on. We're going to have an agenda today of defining and talking about supply chain attack vectors, move into intrusion, execution, and control, examine how this is not all that simple for adversaries, and get into advantages that the defender holds over even the most gnarly of supply chain attack. Slide, please. So the supply chain, we often have this really simplistic view that from start to finish, we start with raw materials, moving through various suppliers, service providers, et cetera, that then get into our own environment, leading on to consumers. However, if we look at the next slide, we will see that we really have something that's a lot more complex. We're really talking about more of an overlapping web of various entities on both the product, services, raw materials, and other sorts of supplier levels, such that we really cannot look at this anymore as being a very linear sort of model, meaning that there's a number of inject points or potential inject points for an adversary to sort of get into the supply chain. Slide, please. So looking at this, we can roughly break down supply chain vectors fairly broadly across products and then services. Products consisting of hardware devices, but also getting into software and code. So we can see both hardware and software vectors in the product line, but also, and it's not important to not overlook, services components of supply chains as well, especially as we work in increasingly connected environments with managed service providers, third parties, contractors, and all sorts of other entities that have access to our networks. Slide. To deal with the product side first, this is fairly straightforward. I think everyone has some understanding of how this works, that we can compromise a vendor or supplier, then leverage that access to design and deliver some sort of capability, and then do bad stuff. Turn the lights off, cause something to explode. Haven't actually seen this really in reality, but that's the nightmare scenario. Slide, please. And we do have some examples of this happening, except they're really crazy examples when we start talking about the hardware side of things. So we have stories from the Snowden leaks about router upgrade factories, and then there was a really interesting story about the crypto AG bonuses that were put into cryptographic devices that resulted in the CIA having full take on what should have been encrypted traffic for a lot of organizations. These are not easy to pull off. And as we see in the next slide, there are more rumors than we have actual examples. For example, the apocryphal story of a CIA plot to blow up a Siberian gas pipeline by planting in the supply chain faulty specs for given devices, which has been fairly debunked. I mean, it's still possible this might be true, but Tom read in the linked article there, and most of these resources are available at the end of this presentation, as well as in the breakout room in Zoom if anyone wants to look at them. But really not a whole lot of evidence to support this. However, if we go on to the software side of things, we start seeing things become a lot more interesting. So here's just a couple of examples. The Shadow Hammer incident with Asus motherboard updates, firmware updates, and the CC cleaner incident. And these were events that targeted or impacted millions of devices. So very widespread activity, although follow-on activity was much more circumscribed. And that gets us into something a bit more recent. Next slide. Oh, I'm sorry, don't know my own slide order. But we've also seen supply chain software impacts in some really interesting and really concerning ICS specific events. Most notably the Dragonfly campaign, which included a very significant supply chain vector through several very particular ICS related software products, and using malicious updates to these products to get into control system networks. Didn't result in any damage or any disruption that we know of. There are some theories floating out there, but certainly shows that, one, this sort of avenue into control system networks is certainly possible, and attackers have done this, and they were doing it almost a decade ago. So this is nothing even remotely new. It's something that we've actually been dealing with for quite some time. Slide. And that gets us to what's potentially the most successful event, although like I talked previously with the Shadow Hammer and CC Cleaner items, those impacted millions of devices, whereas the SolarWinds supply chain compromise, Sunburst, Solorigate, whatever you're calling it, has approximately 18,000 victims, give or take, depending on who you're asking, and then a subset of those seem to be had received follow-on attention. Not too much in the news about industrial specific components of this. Again, there are some rumors to this effect, but nothing that has been publicly disclosed as far as using this as a vector to get into control system environments. But for those who have experience with SolarWinds software or other vendors where this software is incorporated, it becomes apparent quite quickly how this vector could be utilized in order to gain fairly widespread access to a control system network. So even if we haven't seen a concrete example of this taking place, and I believe we have a presentation tomorrow talking about SolarWinds specifically with Mr. Weiss, so we'll probably learn more about that very soon. It still presents a number of very severe concerns for how this might work. Slide, please. But then there are also unproven examples, and I'm sure people were waiting for me to get to these sorts of items. So, there's the Big Hack article from Bloomberg that's been derided multiple times, and I know Monte Elkins brought this up in his presentation at the last ICS Summit, and getting into just the nitty gritty for how you could actually implant a right-sized chip onto a device for purposes, but there's been no evidence really supporting this. So we can't really say much about how this could work. And then there have been some stories about potential PRC related injects into the global supply chain for electric utility products. Very scary stuff, but as we'll see in the next slide, not a whole lot of evidence yet. And again, it's possible, we do have the evidence of a transformer being seized and some other items, but there hasn't been anything publicly available that's really discussed this to the point where it's something that we really need to be concerned about. And there was a SANS defense use case paper that came out, I was going to say earlier this year, but no, this was last year. It's like 2020 has been the longest, 15-month year or whatever so far of our existence, right? But that's also a good resource to look at for this, at least examining the possibility for how this might play out in practice. Slide, please. And then we get into services intrusions. And this is getting not into sort of compromising products, but rather compromising the people that have access to your network, which form part of our supply web, so to speak, of people that have access to our networks. Slide. And these go back a bit. We could look at the Target hack of the early 2010s, early 2010s, where a HVAC company was compromised and through their privileged access into target networks that facilitated follow-on compromise of point of sale systems and then hoovering up lots of credit card details. Like, oh, okay, building controls, that's ICS adjacent, so maybe that's kind of relevant. But then as we start digging in a little further, slide please, We start seeing other items such as the Cloud Hopper campaigns, which are subsequently linked through US Department of Justice indictments to the Chinese Ministry of State Security as a very widespread campaign that, although not industrial focused per se, certainly impacted lots of organizations with industrial assets. Definitely could have used this sort of access to facilitate follow-on compromise or lateral movement into control system environments, even if we don't necessarily have that much evidence showing that that was the case. At the very least, we have to recognize the possibility because, as we see in the following slide, we do have examples of how this has worked out in practice. And I believe Mark Bristow, a couple of years ago, along with a colleague from CISA, presented on this use case specifically. But we had the Palmetto Fusion, Allanite, however you want to phrase this, Dragonfly 2.0 activity from 2017, and really kind of off and on up until quite recently, actually, where a entity believed to be connected to Russian government entities compromised the web pages or email for a number of contractors, including some relatively small, very specific contractors that were very regionally focused and leveraged this access and existing trust relationships to then gain follow-on access to utility environments. And so looking for those relationships between contractors and then who those contractors serve or who they work with was an avenue to enable access to critical infrastructure environments. Slide, please. So that's all well and good. We have lots of examples that get people really scared and worked up about how supply chain attacks work. And we see a lot of focus on the execution of a supply chain intrusion, of how we can potentially implant something into hardware, make a software modification, or compromise a vendor, contractor, or service provider. But then things get kind of murky, and this phase 2 of what do we do then in order to get to phase 3 of achieving whatever our objectives are doesn't get examined as much as it probably should. As we see in the next slide, there is, this isn't an easy process by any means. And this is a very simplified flowchart. I could have made this into quite the eye chart if I really wanted to, that in addition to identifying victims and the vulnerable supply chain relationships, I then have to figure out which supply chain relationships and then follow on activities once that capability has been delivered, if it's been successfully delivered, into an environment before I get to executing or performing whatever desired impact I have in mind. Because as we see in the following slide, looking at this, there's complexities involved in this process. For one, we're talking about at least, if not more than double the reconnaissance and intrusions to make this happen. Because not only do you have to perform reconnaissance for what environments you want to get into, ultimately your final victims or final targets, but also those earlier on items, those suppliers and vendors themselves that you have to break into. So we're at least doubling the amount of reconnaissance and other work in order to make this happen. And that's before we even get into the highlight on the next slide, the various ingress routes and maintaining control over implants so that once we leverage a supply chain compromise to get into an environment that we can do something reasonably useful with. So as we see in the following slide, there are choices that a adversary, intruder, attacker, maybe, although I don't like using that word unless we see a real definite deny, degrade, destroy here, but choices that an attacker faces. And I've mapped this out in a fun quadrant. Maybe one of the consultancies, Forrester, Gartner, whatever will steal this from me, but we can map this out on 2 axes of targeting and control. And we could look at targeting being either very general, like we saw with CC Cleaner, where we just spray and pray all over the place, or being very specific. Similarly, for the actual control over a capability, something can be autonomous, like we saw with, say, a Stuxnet, where it can kind of pretty much do everything on its own, although that wasn't a supply chain compromise, or something that requires very manual control and operation, so that you have to be hands-on keyboard to make use of it. And this maps fairly well, as we'll see in the following image, to items that we have seen in the wild. So in our upper right quadrant, we see Palmetto Fusion is being very specific in victim selection, but involving lots of manual control. Sunburst might be a little bit more autonomous. That's kind of open to debate how autonomous it really was. Certainly wasn't that autonomous in later stages, but at least in initial operations seemed to operate on its own pretty well. But then in terms of indiscriminate targeting, we have Dragonfly, which we already talked about briefly, as being fairly general in distribution. Anyone downloading the software updates was going to get this, but then followed up with what seems to be fairly manual control within victim environments. And then in the complete, we just want to see the world burn sort of scenario, we have something like NotPetya, which started out with a supply chain compromise for MEDoc, a Ukrainian company, and that ultimately resulted in a wiper being distributed pretty much all over the world. So what have we learned at this point, getting into follow-on slides? What we've learned is that adversaries face some constraints, that mapping out based upon how an adversary decides to control, target, etc., that adversaries have some constraints in terms of operational control, how much collateral damage they're willing to put up with as part of a supply chain campaign, as well as just the overall operational security or ability to hide that activity if the adversary cares about not being caught. So as we see in the following slide here, we can break this down a bit further so that we can see challenges that the intruder faces in terms of access. How do I deliver things to targets, but I don't spread too far? How can I maintain communication so I can actually control an implant once it's deployed into an environment I want it to get to, but also avoid detection at the same time? And finally, from an impact perspective, how do I actually achieve my objective that's in play while also ensuring focus on the environments I care about, not spreading too far, not having something that ultimately doesn't work in the environment I play in. And all of these are non-trivial barriers to success that an adversary faces. So as we see in the following slides, adversaries have to ask them questions of how do they get access to a desired target while avoiding other entities? How can they control that capability while maintaining stealth? Even the most robust supply chain capability out there, unless it operates in a completely autonomous fashion, and we don't know of any yet, even Stuxnet required some command and control and external communication. So network security monitoring and network segmentation, as we'll talk about in a few slides here, still comes into play. But also we need to figure out a way to either retrieve the effects package or deploy a capability without being caught, and doing so in a way that will actually work. Furthermore, the supply chain compromise itself, unless you get really lucky and deploy some component directly into a control system, more likely you're operating in a scenario where you get an initial bridgehead in a network and then have to spread out from there. And so there's the possibility of detecting lateral movement or follow-on activity from that bridgehead, which is another area that the defender can take advantage of. Next slide, please. So looking at this, we can identify items like the risk of overspread. This is a plot of WannaCry infractions where we see something just get completely out of control. And again, if you just want to see the world burn, maybe that's fine. But if you're doing something in critical infrastructure, this is how you get a warhead dropped on your development office or something similar along those lines. So you might want to avoid going all out in this fashion. Similarly, as we move to the next slide, we also have the possibility of losing control over something. That could be due to something as stupid simple as there being a line cut or APT backhoe getting involved, or defenders actually wise up to things and pull the plug on our C2 item because they notice that, hey, why do I have this weird funky domain being contacted by a SolarWinds server or by my data historian or some other product? Finally, to use another humorous image in the following slide, there's always the possibility that whatever it is that we deploy in the environment just doesn't work. And this is a non-trivial item because we've seen this in fairly robust ICS-related attacks, whether we're talking the In-Destroyer Crash Override event, the Triton Trisis event, where we've had ICS payloads that once they got into the environment didn't quite work the way that adversaries wanted to, at least based on analysis, that's what we think. And that gets even more difficult when we start talking about trying to deploy things through a supply chain vector where you might not have the best control over what's going on and have to assume what sort of environment we ultimately end up in. So with all that in mind, where does that leave us now? Well, you could say that the attacker only has to be successful once and get into environments, but the defender needs to be right every time. Well, the thing is, as we'll see in this next image, that conception is wrong. Slide, please. Yeah, so we could look at it that way, but the thing is that this compresses the overall sequence of events that we already talked about in terms of attacker dependencies and barriers, such that really we can flip this on its head and say that the defender only needs to be right once in order to catch and mitigate a potential intrusion vector, like spotting the command and control schema, whereas the attacker has to be right every single time. Otherwise, they lose access to their painfully designed, implemented, and delivered supply chain compromise. So for example, moving into the next slide, We see various advantages that we as defenders hold. For one, we own the damn network. We have a home field advantage in that we control the environment the adversary is operating into. Now, to the extent to which we take advantage of that control is obviously up to us, but we have it to start with. And if we cede that to the adversary, that's our own damn fault. Furthermore, we have the ability to start doing things like baselining and determining what normal actually is within our environments, such that when things start acting abnormally, we can detect that or potentially act in such a way to work against that. Finally, we do get visibility into communications, and that could be even something as simple as metadata, identifying odd communication relationships, such as, going back to the Sunburst example, even though it's not specifically ICS, why is my SolarWinds server talking out to this funky looking domain that looks like it's spoofing an AWS domain? That just looks weird. Identifying those sorts of connections can be very vital in unearthing these compromise scenarios and allowing us to begin response. Slide, please. And looking at this, we can even apply this at a greater level when we start talking about control system environments, because IT networks already retain these advantages we talked about. But when we start getting into control system environments, certainly with the caveat that with increased cloud connectivity, which I believe Mr. Foos is going to talk about later on today, as well as what Rob Lee talked about in the keynote in terms of vendors and others having increased access to networks, not to say shadow IT, but where we're implementing things in the strictest possible way, we have the possibility of creating well-segmented and designed networks that can enhance the advantages that already adhere to IT network security and monitoring. And through an overview of proper security segmentation and network control, we can start seeing these benefits in practice. So as we move to the next slide, we'll get into a model that pretty much everyone here should be familiar with, the Purdue model. Everyone knows the Purdue model, right? If you're new to ICS, this is the Purdue model. I don't think it's actually been brought up that much in the conference thus far, but really just a high-level representation of what the various interconnections between levels of network type and control, getting down into the layer 0 actual physical processes of the environment. And the reason I bring this up is that when it comes to supply chain operations, by implementing defense across the entire Purdue model and the entire network stack, we can severely disadvantage attackers and really retain lots of possibilities for stopping these intrusions. So to move to the next slide, certainly this starts in IT. IT and OT working together is pretty damn critical, because visibility and control over external network ingress and egress is pretty damn important. Again, identifying where you see the odd command and control traffic or other sorts of items that an adversary is going to by necessity need to do to maintain control or send commands to any sort of implant. But then after we start, look at the IT realm and start getting into the industrial specific or industrial related items and move into layers 3 and below, we start seeing other advantages show up. So as we look at the next slide, we start seeing the possibilities that at that level 3 plant DMZ or even level 3.5, possibilities exist for proper network segmentation, but also creating choke points, which can turn into monitoring points that allow for us to start examining traffic flows and identifying suspicious items that, again, tap into the adversary's necessity for either trying to send commands into or trying to extract information out of vital networks. So again, short of a completely autonomous sort of solution, which takes into consideration risks of potentially executed in the wrong environment. You would like to make sure that you have positive control over something. That's short of just completely letting things apply to whatever autonomous logic. Adversaries are going to need to talk to whatever it is they've deployed, and we can take advantage of that. And then as we get deeper into the next slide here, we start seeing the possibilities emerge of ICS-specific security awareness and monitoring processes to try to identify strange items such as communication to safety systems or communication to protection systems that are necessary in order to try to disable controls that would mitigate against potential damage, as well as getting into classic discussions of baselining and anomaly detection when we start talking about modifications to the actual physical process itself, beginning at that level 2 and getting into the level 1 layer. Finally, getting into the conception of ICS as being where IT basically meets physics, as we look at the next slide, we're not even done there yet, because physical process and engineering safeguards are in play that make sure that even in the absolute worst case scenario where an attacker has penetrated into an industrial environment and has deployed a malicious capability, we still have the possibility, by implementing engineering controls and safety controls, that we can prevent worst case scenarios from developing, even if it does result in some level of disruption, that we prevent possibilities like the plant explodes because no, we had a blowout valve, which resulted in the overpressure situation being mitigated. So moving on, what have we learned thus far? Well, we've learned that there's a number of ways that we can start acting against and responding to supply chain compromises, especially in an industrial environment, but that requires that we do some homework, namely having things like proper asset identification, actually having visibility into traffic and control of what traffic flows into and out of our networks, as well as the ability to properly segment, especially critical areas of our network, all come into play. But then I think one thing that gets overlooked a lot, and where SANS events like this are very wonderful environments, we also need people that are capable of both applying all of these items as well as monitoring and acting on what sort of data we extract out of asset identification and communication mapping, traffic monitoring, and response to traffic anomalies. We need to empower and inform our network operators, our plant operators, and others to look for and understand these sorts of vectors, so that when an adversary gets lucky and successfully deploys some sort of supply chain intrusion methodology, that we retain that own network advantage and can spot them as they try to gain control over whatever capability has been deployed. So to conclude on the final slide, attackers are increasingly seeking to subvert trust relationships. I mean, this is not something new. It goes back decades in many cases, but we're seeing more and more attackers, especially on the software product and the services vendor side, try to achieve these sorts of goals. But if we recognize that defenders retain natural advantages in these environments, we get the possibility of detecting and defeating these intrusions by taking advantage of adversary dependencies. Through a combination of secure architecture, network and host visibility, and active monitoring of what data is available to us, we can regain that defender advantage and really take the fight to our adversaries, such that supply chain compromises, though still pretty nasty, aren't the boogeyman or whatever that they've been made out to be in the press. So that's it for my prepared content. I know we had some both timing issues as well as technical issues. There are a number of references linked to this in this poorly formatted slide. I should have checked this before I submitted it. These references are available in the Slack breakout room. I don't know if we have time for any interactive questions, but I'll be hanging out in the Slack channel for follow-on discussion. So thanks everyone for bearing with some technical issues, as well as my usual speedy presentation style.
Oh, Joe,
I am available.
Fantastic.